Hi, in this video I'm going to show you guys question number 6 from exercise 13K. So here's the question. They want us to make a sketch of y is equal to negative sine of inside the big parentheses here we have negative 2 multiplied by x plus pi over 4 in parentheses, close parentheses, minus 1. Okay, so there's a lot of stuff going on here, right? But before we actually start making a sketch for this, I want to show you guys something. So I have used Desmos, and I put this equation in my Desmos, and this is it, right? So negative sine multiplied by negative 2 x plus pi over 4 minus 1. So I typed my equation correctly, and my angle is in radian, so everything is good. My graph, the red color graph, that's what we have for the equation that we need to sketch later. So my sketch later on should look very much the same. So I should get a maximum point, minimum point. My principal axis for now seems like it's at y is equal to negative 1, right? And my period seems like it's going to be pi, right? And the principal axis again is negative 1. Okay, so my sketch should look very similar to this later on. But the reason why I'm showing you guys Desmos is not to cheat. It's actually this. So if you look at my second equation, my second equation is almost exactly the same as my first equation. So there's no negative sign outside, right? It's just a positive. And the negative 2 for my first equation, that becomes a 2. And I'm going to show you guys, I'm going to display the second equation, the graph of the second equation, and you guys will see something very weird. You see that? See that? So what does it mean? These two equations, they give us the same graph. In other words, they are the same, right? That's kind of weird intuitively, right? So in this video I'm going to explain to you how the heck did that happen, right? So let's go back to my notepad. Okay, so in order for us to understand this, we're going to go back to our unit circle. Okay, so let's say this is my unit circle, right? And say today I have this angle there, and I have another one down there. Oops, sorry. Let's say this angle here, let's call that angle theta. Okay, so for now, nothing new. And the x coordinate would be cosine of theta, and the y coordinate would be sine of theta. Right, so far so good. This is my x, this is my y, right? Okay, now let me see a different color. Let's say today they want us to say I want to find the location for negative theta. So if going up this much is theta, then if I want to find the location of negative theta, I have to go down and I have to go in the opposite direction, but the same amount, right? So I'm gonna be somewhere there. So I'm gonna go down just as much, but in the opposite direction. So this angle here will be negative theta. Okay. Now what's the x coordinate going to be? The x coordinate will be cosine of negative theta, right? That's the angle. And then the y coordinate will be sine of, again, the angle, negative theta. All right. Now, if we compare the x values, the x coordinates, and the y coordinates, let's see what happens. Okay, we're going to compare the respective x values and the y values. What can we say about the x values? That they are x coordinates. What can we say about them? What do you think? I hope your answer is they are the same, right? So cosine of negative theta is equal to cosine of theta, right? Because they are on they are on the same x. They have the same value, right? They have the same value. Now let's look at the respective y values. So sine of negative theta is here, right? This is my sine of negative theta, and for my sine theta, it is all the way up there. It is this one, right? So sine of negative theta is equal to 1. Sine of negative theta is simply equal to negative of sine theta, right? Okay. Therefore, another way to say this, maybe it's easier for us to look at a few angles. So let's say today I know that cosine of pi over 4, that's going to give me root 2 over 2, right? So let's say today they want us to find what's the cosine angle of negative pi over 4. Cosine of negative pi over 4. So I'm just going to use this one, the first pattern that we saw. That's actually that's actually one of the rules, right? But if you can construct a unicircle, we don't really have to remember them, right? So I wouldn't call them rules then. So cosine of negative theta is the same of the cosine of theta. So cosine of negative pi over 4 will be the same as cosine of pi over 4. So it would also has a value of root 2 over 2. Okay. Let's say if I want to find sine of, just for example, maybe pi over, say, pi over 6. Right, sine of pi over 6, that gives us, I think it's 1 over 2, right? Is that it? Let me just check. Okay, yep, sine of pi over 6 is 1 over 2, right? So today, if they want us to find sine of negative pi over 6, so that would be, so I'm going to use the second one now. Sine of negative pi over 6 would be the same, would give us the value of negative of sine pi over 6. So sine of pi over 6 is equal to half. This is equal to half. So I have negative half. Alright, so ultimately what we're talking here is this. Okay, now I am going to copy this. I'm going to copy this, and when you guys come, I'm going to pause the video and copy it. When you guys, when I come back, you guys will see the two equations here, the two rules that we have here, back on question number 6. Okay. Okay, so let's go back to question number 6. Now, in this case, we have a sine function, so I'm going to look at this one, right? And what I'm going to do is I'm going to treat this part as theta. So my theta, I'm going to say theta is equal to 2x plus pi over 4. Okay, so which means I can simplify my equation as negative sine of negative theta minus 1. Does that make sense? Okay, now I can simply apply my rule over here, because sine of negative theta is equal to negative sine theta. So I'm going to have y is equal to, so the negative here, I'll keep it there, right? But this part becomes negative sine theta, right? And then the minus 1 stays there. So now the negative and the negative, they will cancel out each other. We will end up with only sine theta minus 1. And now we can bring the theta back. My theta is equal to 2 times x plus pi over 4. Let's bring it back. So I have sine of 2x plus pi over 4 minus 1. There you go. Our original equation now looks exactly the same as my second graph on Desmos. My second graph on Desmos. Okay? And therefore, when we are asked to sketch the original equation, I can mess around with I can use my algebra skills, and I can also use our knowledge, right? Our knowledge of low battery again. Sorry about that. I can use this to help us to mess around with the equation, and I see that this equation looks something that looks very complicated would give us the same graph as something that's very straightforward. So in this case, my A is equal to 1, right? My principal axis is -1. My amplitude is 1. Principal axis is -1, and this is my B. So period is equal to PERIOD. Sorry, PERIOD is equal to 2 pi over my B in this case is 2. So my period is equal to pi. And I have my C is negative. C is negative pi over 4. So this is a shift to the left. This is a shift to the left by pi over 4, right? So if I sketch this, my principal axis is here. This is -1, and so my sine graph, a regular sine graph look like that. I'm going to move this point to the left by pi over 4, right? So I will have, this is my pi over 4, negative pi over 4, sorry, negative pi over 4. So now this point would end up here, okay? And then I think my y-axis is a bit off. So what I'm going to do is, let me redraw this. Let me redraw this whole thing, and I'm going to put my y-axis a little bit on the left, so I have more space for this graph, right? Okay. So I have negative pi over 4 here. So since I'm moving this to the left, so I'm going to have, that's my starting point. But I'm making a mistake here because my principal axis should be -1. So that point should not be there. My principal axis is at -1. So this is my principal axis. So I should have a point there. Okay? So this point now becomes there. Alright. Then my period is pi. So so this thing will go up, come down, and back there at pi, right? So this go up, come down, and the period is gonna be pi. So which means if I were to find the end point, the end point will be, I'm gonna do this on the scrap paper, negative pi over 4 plus pi will give us, what's that? This is 3 pi over 4. So from negative pi over 4 to 0, I'm kind of doing this in my head. I skipped from negative pi to 0. Sorry, negative pi over 4 to 0. I added pi over 4. Right. So if I have another one here, that will be pi over 4. Right. And another one, that will be 2 pi over 4. And then another one, that will be 3 pi over 4. Okay. So I'm starting from here at -3 pi over 4. I'll back to where I started, and so that's this point. This point becomes that, right? This point right there, it will now be here, right? So I'm gonna have another point here. My maximum is gonna happen at 0, and the amplitude is going to be 1, so it's going to go up to there, 0. So my max is equal to 0. My min will be -2. So I should add another -2 over here. This is -2. So my min is going to happen at 2 pi over 4, and the y value will be -2. So I just go up, come down, go back up. Just kind of give myself a little bit more on each side, and that's it. Okay, this is a sketch of question 6, exercise 13K. Sorry about the lengthy video, but I hope you guys find this helpful. I'll see you guys. Bye.